Hello, Lucas. Thank you for joining.
Thank you.
So we reached now our slot for vehicle energy and driving attributes. And also here, many new things are coming up because of new customer requirements, new operating, new technologies. So I'm curious, what is new in the area of vehicle dynamics?
Okay. So it's a pleasure to be here. I would start with the new topic for off-road passenger cars. So we had off-road many years for commercial vehicles and tractors, but there is a trend also for passenger cars to the increased number of crossovers, SUVs, and also the electrification topic, which enables cars without changing on the hardware, just on the software side, to improve the off-road capabilities. So this is being requested by different OEMs and suppliers to improve the usability of the car, the experience of the driver, and so on.
Why do you see the trend that this goes into virtualization and doing not everything only with hardware testing? What is the intention?
Yeah, one of the main topics is that off-road is very difficult to test in a real environment. So every time that you drive in an off-road track, the soil conditions they change. You need to prepare the soil again to make them repeatable so that you can make calibration of your functions, vehicle controls, traction controls, and so on. By bringing this to office or even real-time applications, you can easily keep the soil conditions or degrade the soil or change from mud to dirt road to snow, sand, and so on in a few clicks, so that you can save a lot of time doing testing, calibration, and so on.
So also repeatability is I believe, an issue here, which is much easier to do in virtual environments.
That's the main pain point from many customers, many OEMs and suppliers. So on road, yeah, the track conditions are more or less stable. Sometimes rain and weather can influence, but off road it's always changing along the day when the car is moving there and other people are testing. So then we can save much more time for off road applications.
So, and what type of maneuvers are possible there, and what are typical use cases which are tested here?
Yeah.
I think there's a wide range of different possibility, I believe.
Exactly. So we can start from the maneuvers that we just presented, like from the longitudinal performance and so on, up to the example now, tank steer. So this is just a special case. Some markets they promote the capability of a tank steer when the car has 40 views and can be able to make such a move. But of course, the traditional, normal use cases like going out in a hill climb or even braking, performance of braking. So would be the main points.
So this means also for special purpose vehicles, you can set up such maneuvers which are then not typically what we are used from passenger cars, I believe.
Correct. We tested a lot of cars from very I would say street-oriented cars using street tires and so on under off-road conditions. But we also tested off-road cars, off-road tires, so IC, BEVs, during the last few years to make the correlation, to make the software, VSM software possible to cover this topic.
Yeah, switching now from vehicle dynamics to another topic, which is the model factory. We have the model factory available now for passenger cars quite some time, and I heard that something is coming up for commercial vehicles as well.
Exactly. So 3 years ago, we started with vehicle model factory for passenger cars. It was very well accepted and used by different markets, and different customers also wanted to have this for trucks. So then we also did testing in collaboration with our colleagues from AVL benchmarking team, and we tested this data also for commercial vehicle measurement data that was applied to the vehicle model factory workflow. And in this release, we have this implemented to cover different areas like hose down, EDUs, battery, braking performance, and so on.
From the setup and the usability, what is the difference now, passenger car to commercial? What can the user expect here as the main differences in the usage?
Yeah, the usability is very similar from passenger cars. So basically, you can start from very few inputs, as you can see in the video, and then you can load the measurement data. In this example, it's a brake maneuver for a small truck. 3 measurements put together, and then you can just process this through vehicle model factory. So considering that you already set in the beginning the vehicle weight and the wheelbase and main dimensions, and then you would have the KPIs already checked. So the brake distance would be already placed. You can compare real testing and VSM, and you can also apply this to the final model. And you do the same for the EDU, battery, brake, and so on.
To set up the models, measurement data are required. What is here the difference from the demand of measurement data, passenger car compared to commercial? Is this more difficult, or what does this mean?
Basically, we have similar approach. The advantage is that most of the commercial vehicles, they already have some data acquisition on board, or even use SAE 1939 protocol. You can record a lot of channels that would lead to this correlation, or even GPS, which is normally available inside the truck as a built-in device. You can also include the GPS data. Reusing existing data as well. So normally testing departments, they have a lot of data available.
So the entry barrier on commercial powertrain is not higher, but even lower because they have more onboard data already built in the vehicles.
Exactly, and the protocol is defined. So you don't need any reverse engineering to find a lot of channels. So you already have many of them available through this SAE protocol.
Yeah. What in a case if no measurement data are there, is there also a possibility to set up models now and adjust driving performance models of vehicles without data? What possibilities do the user have here?
Yeah, that was one request from different customers. So normally when data is missing from specific areas, it would be like necessary an expert to cover this gap. And based on experience, he would check the model, change the input data, look to the measurement, and apply the corrections. What we implemented to cover this gap, also that during the beginning or the initial phase of model buildup, you can immediately fit them. We created this vehicle model generator, which takes not measurement data, but physical parameters like acceleration time, physical KPIs, brake distance, and so on. And then the model will be fitted. So you basically select the vehicle class, the body style, a base vehicle would be used, and then you can adjust the inputs that you have for this vehicle. That would be different dimensions, different physical, let's say, conditions of the vehicle. And then you have the KPIs on the right side so that you can also change them. So if you have an acceleration which was 6 seconds, but you know that the car is making 5.8, you can just type the brake distance, the range, and so on. And VSM, through artificial intelligence, will rework this model, these areas that measurement data was missing, and then create the new model. So this is not only a standalone solution, this can be used with vehicle model factory and can also be used for existing cars that the OEM already have.
So I assume this is a very great feature in concept studies when the vehicle does not exist. You can play around more or less and already adapt according to target values, I assume. Are there other use cases where this is important?
Yeah. Whenever measurement data is not available or the prototype could not test this or that maneuver because of some limitations, we would use this to cover the missing point.
And finally, when the models are available and you have different concepts with different target values, how does the results look like and the investigation, how do you compare the different concepts?
Yeah, you can directly compare two cars. In this example, acceleration that was not matching for one car and then was fixed. And yeah, you can also compare by plotting graphs and look what is fitting to your existing KPI. And on top of that, you can also, along the development process, update this model. As soon as data is available, you can just apply vehicle model factory again for that area. Or if input data, detailed maps are available, you can put them directly in VSM.
Yeah, that's a wide range of new capabilities, new generators, new functionalities. How can the user now get access to it?
Okay, so the vehicle model generator is part of VSM base. The off-road and the truck topic is part of the add-on off-road and add-on commercial vehicles. And all these topics are also part of the new vSuite 24R1.
Yeah. Thank you, Lucas, for joining. Thank you, Lucas, for introducing these capabilities.
Thank you, Oliver.
Yeah. And to all participants, thank you for joining. Please reach out to us and contact us if you have any questions, if we can help you. And with that, I wish you a lot of excitement experiences with our new release.
Thank you very much.